Hello, friends. You are welcome again on our channel. As you know, we always try to learn you something which is very complex and tough in an easy way. So, today we are going to learn why, where, and how machine learning is important. As you know, machine learning is a booming career option nowadays as a data science for the students and for the professional also. So it's we will try to understand this in a very easy way. Why machine learning, where and how? As you know, machine learning is just a concept from the AI. It's artificial intelligence. Without machine learning, AI is not possible, and without deep learning, machine learning is not possible. So you can see AI is a big circle, and machine learning is a part of that AI, and deep learning is a part of that machine learning. What is AI actually? A science devoted to the making machine think and act like a humans. It's a artificial intelligence. And how that machine learn? So machine learning comes here. Focus on enabling computers to perform tasks without explicit programming. So that is the way we let machine learn the human's language. And what is deep learning? The subset of machine learning based on the artificial neural networks. So, guys, let's focus on the machine learning today only. We will not see anything like artificial intelligence in deep learning. So, what is machine learning? If we talk about the as a human, how human thinks, how human learn, I can learn everything automatically from my experience. Can you learn? That's the same word come from the machine. Okay, I can also learn from the history. If a human can learn from his experience from history, so a machine can also learn. That is all machine learning. How it work actually? Let's see some practical how the Reddit comments, Twitter, YouTube, and news feeds, how they use this machine learning. So what they do, they actually play with the data. If I talk about the data, data can be in the form of image. Data can be formed in the topics, sentiments, language detection, and any music, any sound, any type of data that can be used. So the machine learning, they learn from this type of data and provide output. That is visualization of the output. That is called how it works in every pilot form. If I talk about the machine learning, that is also divided into many parts. It's not like a same way. We can say it's a supervised machine learning, unsupervised machine learning, and reinforcement of the learnings. So how this learning is divided, this is all depends on the type of the data only. If the data is labeled and it's a numerical form, that can be supervised learning through. If a data is not in numerical form, it's an image or unlabeled data, that can be done only with the unsupervised learning. If anything comes with the action, that can be done for the reinforcement learning only. So you can see that supervised learning are the two types: classification and regressions. Unsupervised like a clustering mostly, and reinforcement is done by the environment and action. We will see this in the very details. So, what is supervised learning and supervised learning and reinforcement? If we try to understand this in a broader level with the help of these three peaks, so you can see in the first peaks, in the supervised learning, we have a teacher available who is teaching you actually. That teacher is giving you training, you are learning this data and performing same task but teacher has given you. That is supervised learning. If we see the second image, we don't have teachers available here, but we have the resources available like books, everything what we need. We have to learn it ourselves. We have to decide what we have to learn and how we have to learn. That is unsupervised learning. If you see the third image, we can see a nice robotic there, right? There is nothing like a trainer is available. There is nothing like the resource is available. So only a robot is available. That is action. So whenever we will give any a task to this robot, this robot will think and use its own brain and the past learnings and perform that action. That is called reinforcement learning. Let's see this in detail now. How machine learning is divided into supervised, unsupervised, and reinforcement. There are two words always we are using. Data is labeled and data is not labeled. What does that mean? Let's see this first. If I talk about the data is labeled and we will go for the supervised learning. So the labeled data, it means the labeled input is none as a output. Output is very well defined in this type of data, or target is defined very well in this type of data. If we found both things, then we will go for the supervised learning. If we talk about data is not labeled, it means we have to understand the pattern and discover the output. That means output is not defined. Target is not defined in this type of data. We have to understand the pattern and discover that. That is called unsupervised learning. If we use supervised learning, that can be two types: classification and regression. And there are famous classification learnings like logistic regressions, navy wise, k nearest, and support vector machine. If we talk about what types of examples we can do there, email spam detections or speech recognition, that all can be done by the classification learnings. If we talk about the regression are the only four types: linear regression, ridge regression, ordinary least squares regression, stepwise regression. And what type of pattern we can do through the regressions? It's a stock market prediction, rainfall prediction, means the mostly numbers are numeric and target is defined here, right? That is all supervised learning. If we talk about the unsupervised learning, that means the data is not defined, target column is not defined. So that can be done a three way. First is clustering, second is association analysis, and third is dimensional reductions. If we talk about the clustering, that means the K means K median, hierarchical clustering, expectation maximization. So this types of done through the examples like the fake news identification, documents analysis. This is all done through the clustering method. If we talk about the market-based analysis, it's a can be done by the associate analysis like appropriate, escalate, FB growth. If we talk about the dimension reduction, that is done by the PC and LDA. There are two famous techniques are here, right? So we can done. And what type of data we can analyze here? Analysis of written text and DNA micro array data types. If we talk about the third one, that is enforcement learning, it can be done by the state and action. There are two things only: model free and model based. Model free are three types basically: Q learning, hybrid, and policy optimization. If we talk about the model based, it's a learn the model and given the models. Now let's see something in details now. Now we in video we will learn what is the supervised and unsupervised. Linear regression, linear model is a supervised techniques, and we can see there are four techniques mainly: linear regression, logistic regression, ridge regression, and lasso regression. What is that actually? We talk about the linear regression. It's a simple algorithm that models a linear relationship between input and continuous numerical output variable, right? So we can see data is defined. It's a numerical type. That is all can be done by the linear regression. And where it is used mostly, if we see use case, linear regression can be used for the stock price predictions, prediction housing value, prediction customer lifestyle value, prediction sale, anything that is in numeric, continuously format, and we can learn from the past data and can predict this. That is all linear regression. If we talk about the logistic regression, it's a simple algorithm that models a linear relationship between input and a categorical output. The data type is not numerical here, it's a categorical, right? It's yes or no. Or some classes are defined only, right? Where it is used for the credit risk score prediction. It's a customer churn prediction, it's a yes or no types of prediction we can done through the logistic regression. If we talk about the third one, ridge regression, the part of the regression family. It penalize features that have low predictive outcomes by the sinking their coefficient closer to zero can be used to classification of the regressions. Where we can use this its problem, predictive maintenance of the automobile or sales revenue predictions. That is all done by the its regression. If we talk about the last one, less of regression, what is that? Part of the regression family. It penalizes the features that have low prediction outcome by the sinking their coefficient to zero. Can be used for classification or regression. Where we will use that Lexo regression. It's a predicting housing price, predicting clinical outcomes based on the health data. So there are the four famous linear models. If we talk about the Next, supervised learning. This is tree-based model. So we can see there are mainly five: decision tree, random forest, gradient boosting, XGBoost, light GBM regressor. What is decision tree? Decision tree models make decision rules on the feeder of the produced predictions. It can be used for the classification or the regression. So we can use decision tree for the both, where it's not defined, it's a classification type or the regression type. We can use decision tree there. And where it is used, customer churn prediction, credit score modeling, and disease predictions. If we see the what is random forest, an enable learning method that combine the output of the multiple decision trees. Right, guys? In a above line decision tree, we are talking about the one decision tree where we can use for the classification and the regression problem. But in random forest, you will have more than one decision trees. So that is random forest. And where it is used, same data is more big, right? Credit score modeling, predicting housing prices, anything we can use that is random forest. Where we have more than one decision tree. What is gradient boosting regression? The gradient boosting regression employ boosting to make predictive model from an enable of the big predictive learner, where the means we are not getting enough data, but we have to predict. Their gradient boosting is very good. Where this is used for the car emissions prediction and the ride hailing for the fare amounts. What is XG boost? Gradient boosting algorithm that is efficient and flexible can be used for the both classification and a regression task. That is called XG boost. Churn prediction, claim prediction of the insurance, everywhere we can use that XG boost. If we talk about the last one, light GBM regressor, the gradient boosting framework that is designed to be more efficient than the other implementation. Here we use light GBM regressor. And what is the case? We can use this mostly predicting flight time for the airlines and predicting cholesterol level based on the health data. Now, guys, let's see the unsupervised learning. In supervised learning, mostly we deal with the clustering and associate. Clustering means K-means, hierarchical clustering, and Gaussian mixture models. These three are very famous. If we talk about the what is K-means, K-means is the most widely used clustering approach. It determines K clusters based on the alludence distance. So in the K-means, we just go for the means and the center point, and with the help of that center point, we divide our data in the different same type of you can say segment or data types, data taste. Its clusters are made. That is called K-means. And where it is used, customer segmentation. This is very important. We segment our customer on the basis of their choice, their age, their purchasing power, their market value, everything, their location. And what is recommendation system? We recommend it based on the clustering. What is hierarchical clustering? A bottom-up approach where the each data point is treated as a own cluster, and then classes to cluster are merged together natively. So we just try to make the hierarchical clustering based on the data type each. That is called hierarchical clustering. Where this is found, it is always used in a fraud detection and the documenting clustering based on a similarity. We just follow the bottom-up approach, and we just try to club same type of data on the basis of their taste, their what means what is our objective. If we talk about the Gaussian mixture, a probabilistic model for modeling normally distributed clusters within a database, that is called Gaussian model. And where this is used, this is same type. We can use this for the customer segmentations and recommendation systems also. If you will see, K-means and Gaussian mixture model is almost same, right? We can use, but depends on the techniques is different. If we talk about the association, it's a priori algorithm. Rule based approach. This is rule based that identify the most frequent item set in a given database where prior knowledge of frequent item set property is used. This learn from its own data and use the prior data, prior learning, and apply the data and segment that data according to that. It's a rule based approach. If we do the rule, If the age between 20 to 30 will fall the our high demand customer, so that rule will bug there, and the people who are aged between 20 to 30 will segment automatically to high demand customers. That is called a priori algorithm. And where this is used, product placement, recommendation engine, and promotion optimization. Okay, guys, if we talk about the a small process of whole data scientist, if we are it's a five steps. We always try come with a collection, cleaning. It's a EDA, exploratory data analysis, model building, and model development. A data engineer do only collection and cleaning. A data analyst always do play with the clean data and do a EDA. EDA means the cleaning of the data. A machine learning engineer always build a model building and model deployment. If we talk about the as a data science test, you have to done all the job together. You have to work like a data engineer, collects the data, do the cleaning. You have to work like a data analyst. You have to do EDA, and you have to do a work like a machine learning engineers. You have to build the model and deployment the model. That is all data scientist work process. If you just try to learn this cheat sheet, this will help you how and right algorithm is selected. This is not a broader level, but you can learn this easily. How right algorithm selected. Let's start from the start point, right? If you have collected some data, now the dimension reduction. Yes, if dimension reduction is necessary, then you will move to this section, unsupervised learning, where we have many techniques like PCA, SVD, LDD, LDA, which will help you to reduce the dimension. Right? You can see if a topic modeling, we will go for the LDA. If it's no, we will go for the PCA. If topic modeling is yes and probabilistic, we will go for the LDA. Otherwise, we will do for the SBD. Once dimension reduction is done, then you will move to the data type. If the data type is numeric, then move to this supervised learning. It's not unsupervised learning, right? In supervised learning, you will see K model is there, key means is there, GMM is there, DBScan is there. That's all depend hierarchical. If your data is hierarchical, you will go for the hierarchical clustering. If no, then we will specify the K, we will categorize this, we will do the K model. If category is not defined, we will do the categorical data, we will divide the K means and GMM. Otherwise, if we have to define we not need to define the K, then we will go for the DB scan, right? If we go down, have response, yes. If prediction is numeric, then we will come to this section, right? Random forest, gradient, neural network, decision tree, linear regression, because all the data type is numeric. You can see this. If data type is not numeric, this is all classified, we will go for this. KNN, neural, gradient, random forest, decision tree, logistic regression, everything is the data type is not numeric. So hopefully, guys, you understand this small cheat sheet how this is decided, which types of algorithm we have to use and where, and from where we have to move to data for LDA, data for unsupervised learning, data for clustering, data for supervised, data for unsupervised. Thank you, guys. I try my best to understand you well. What is the machine learning, why we use, and how we are using this. If you have any questions, you can refer my other videos also. You can see that a link given there, or you can follow and like and comments my